Sixth grade lesson 9.5 is equations and graphs. So we looked at graphs in the previous lesson and how to graph items from a table. Now we're going to look at equations and see how they relate to those graphs. So let's talk a little bit about solutions to equations just to refresh our memory. Remember we earlier were looking at equations that were having those two variables in it and we're like, okay, well, I don't know. I can't solve this really because there's two variables, there's two unknowns. But we could say possible answers, right? We could say, well, okay, if x equals 2, then I can add those together to get a y. If x equals 3, then I can add these together to get a y. And so that's kind of what we're going to be doing with this. We're going to just import some possible values for x to see what happens to y. So one possible solution for x and y, and I'm going to put that as coordinates or as ordered pairs like we did before. In this case, it's going to be 2 and 5. X is 2 and y is 5. Because if I substitute 2 in for that x, 2 plus 3 is 5. Y becomes 5. Another possible solution could be 3, and let's find out. Let's substitute 3 for x. This 3 stays the same. What will y become? 6, right? There's a possible solution. What if we called x 4? Okay, so I'll plug 4 into this equation here. And if I do that, if x is 4, then y becomes 4 plus 3, which is 7. And so all of these are possible solutions for this equation. Whatever we needed to do to x, what would make it true? What is y going to be that makes that true? And these are the possibilities. There's lots of them, right? And so we use a graph to show that there's lots of them. Instead of listing all the possible ones, we could go on forever. Y could be 5. X could be 5. X could be 10. X could be 1,000, and I can still calculate that. I don't want to calculate that many times, right? A linear equation is something we'll talk about. That's when an equation, when you graph it, ends up showing up as a straight line. Linear line, right? That's easy to remember. So if you graph an equation, and I'll show you how to graph these equations. If you graph an equation and your dots all line up where you can put a ruler down and draw a straight line, it's linear. It's a linear equation, and you'll be working with a lot of those over the next couple of years. So if they form a straight line, linear equation is what that's called. And you'll be seeing that throughout this lesson, some linear equations. It's showing that a repeated pattern is happening. So we're going to be dealing with pattern, noticing our patterns and everything like that. So let's look at this, unlock the problem. And still I know transferring a word problem into an equation that has two unknown numbers is still something you're probably fleshing through, trying to get the hang of. It's not something you have full confidence in yet, most of you. But with practice, I promise you, it becomes easier. So, of course, I'm here to walk you through. We have a blue whale swimming at an average rate of 3 miles per hour, 3 miles per 1 hour, right? Write a linear equation that gives the distance y in miles that the whale swims in an unknown x amount of hours, and then graph the relationship. So the two unknowns we have is how many hours, and they told us to call those x, and how far in that many hours, and they told us y. Okay. So, and they walk us through step 1, write an equation for this relationship. Let's circle what information we have here that they did give us. Write an equation. How far is he going to go after he's swam for such and such amount of hours? We don't know. We're going to call that y. Don't know. But distance we decided was y. But we'll know once we calculate it. And we do know the rate. He goes 3 miles in 1 hour, then another 3 miles in another hour, and then another 3 miles in another hour. So it's going to be 3 multiplied by, they use the dot, you could use the little multiplication sign, either one, multiplied by however long that whale is going to swim. Remember, we don't know. 3x. So we have this equation y equals 3x, because by now you recognize, hopefully, that this number next to this variable, this is called the coefficient, when they're together without an operation showing in between, that it is multiply. Okay. This part looks tricky at first, but then once you see how it works, it's not tricky at all. I have this equation, and if you don't mind, I'm just going to turn them. It's an even scale, right? Even scale. So I'm just going to kind of flip-flop them and put the 3x on this side and the y on that side, if that's okay with you. Does that make sense? I just took this 3x and put it on this side, put the y on that side. It's still the balanced scale, and it's still the same values, right? They're equal. It's the same statement. The reason I do that is because when we use the table, we like the y coordinate to be over here. We have the x here, we have the y over here. So on the table, we have 3x equals, you can even put the equal here, y. So I just took this equation and put it right here. Now, I don't know how long he's swimming, how many hours he's swimming. So we're going to make up numbers. And why make up big numbers if we don't have to? Let's make up some small numbers. Let's say, what if he goes 1 hour, 2 hours, 3 hours, and 4 hours? We just want 3 or 4 points on our graph. If we have 3 or 4 points, we can lay the ruler down and graph it out. So you only need to do 3 or 4. And choose easy numbers. So let's do 1, 2, 3, and 4. Those are super easy to calculate with. I'm not going to choose 4.3 if I get a choice. I'm going to use really easy numbers to calculate because I want to do it fast. And then I will take this x and plug it into my equation and say now it's, instead of 3x, it's 3 times 1. 3 times 1 is 3. Then if x is 2, I'm going to plug it in for that x instead. So it's 3 times 2. And 3 times 2, as you know, is 6. And if x is 3, then I'll plug it in for that. 3 times 3 is 9. And if x is 4, then I'm going to plug it in for that x there. 3 times 4 is 12. And so here I have my ordered pairs. When x is 1, y will be 3. And they wrote it as an ordered pair so that we're ready to graph it. When x is 2, y will be 6. Ordered pair, 2, 6. If he swims for 3 hours, he will have gone 9, was it miles? Yeah, miles. When x is 3, y is 9. And if he swims for 4 hours, he will have gone 12 miles. So that's how we got those ordered pairs. We start by finding the equation, getting it on this table this way, making up 4 simple numbers for x, 1, 2, 3, 4, or 0, 1, 2, 3. I usually use 0, 1, 2, 3 myself, but 1, 2, 3, 4 works too. Nice and easy, right? And then you get those ordered pair x, y, because if you plug it in, then you get the y, x, y, x, y. So those are all the possibilities. Well, not all the possibilities. 4 of the many, many, many possibilities. The graphed line is going to tell us all the possibilities. So let's graph that, just like we did in the previous lesson. I will go 1 on the x, turn, and then go 3 on the y. 1 on the x, turn, and go 3 on the y. And wait a minute here, there's no 3, right? But we all know by this stage that here's 2, here's 4. 3 is right in the middle of 2 and 4, right? 2, 3, 4. So we could go right in the middle of the 2 and 4. And so they did that. 1 on the x, turn, 3 on the y. So we have to use some logic sometimes if the numbers aren't showing. Then the next one is go 2 on the x, turn, and go 6 on the y. 2 on the x, turn, 6 on the y. Mark it right there. Next one, 3 on the x, turn, and go 9 on the y. 3 on the x, turn, go 9 on the y. There's 8, there's 10, so right in the middle of 8 and 10 is 9. And then 4 on the x, turn, and go 12 on the y. 4 on the x, turn, 12 on the y, right there. And then connect with a ruler. Oh, that was not bad. And there I have a straight line. A linear equation will form a straight line when you graph it. And so this does. And what this graph is telling us is all the other possible answers on and on forever. That's why we draw the arrow. If he goes 5 hours, there's 15 miles. If he goes 6 hours, 18 miles. If he goes 7 hours, wherever that ends up. Now I don't have to calculate them all on a table. It just says just all these are answers, right? And so that's what that represents. Okay, so this example kind of does something in a little, it's similar, but a little bit in reverse. They don't give us the same information the other one did in terms of like what the rate is. The other one he went 3 miles per hour. This one doesn't tell us, but it gives us data over here that we can use to figure it out. And this is where I mentioned where we use patterns, our knowledge of patterns that we learned way back in kindergarten. So you'll see it all happen. The graph shows the number of beaded necklaces, Y, that Ginger can make in X amount of hours. These are necklaces. This is how many hours. Write the linear equation for the relationship shown by the graph. So we'll use the ordered pairs from the graph to complete the table of values below. So here's 1 on the X, 2 on the Y. We'll use that ordered pair. They already put 0 on the X, 0 on the Y. 1 on the X, 2 on the Y, right here. Okay. Then we have 3 on the X, 6 on the Y. They gave us the ordered pairs. So when X is 3, Y is 6. And 4 on the X, 8 on the Y. That's that point, and that's the ordered pair. They gave it to us. The only reason I kept dragging you through where they're at is because I'm getting your brain to recognize the graphing piece of it. 4 on the X, 8 on the Y, those coordinates. So when X is 4, Y will be 8. And again, this was how many necklaces she made in this many hours. So in 0 hours, she makes 0 necklaces. That makes sense, right? In 1 hour, she can do 2 necklaces. In 3 hours, she can do 6 necklaces. And in 4 hours, she can do 8 necklaces. So I'm going to ask you, what pattern are you seeing happening? What do I do to X, calculation-wise, to get it to become that? What do I do to 1, calculation-wise, to get it to become a 2? I would multiply by 2. Let's check it. Is 3 times 2 6? Oh, yeah, it is. Okay. Is 4 times 2 8? Oh, yeah, it is. So each Y value must be being multiplied, each X value must be being multiplied by 2 in order to get the Y. Each Y value is twice or 2 times the corresponding X value. I'm multiplying my X's by 2 in order to get Y. So the linear equation for the relationship is Y will equal 2 multiplied by whatever X is. That's the linear equation they want. That's how they want it to look. 2 times whatever X is. And then they show us like, oh, here, that's an answer, that's an answer, that's an answer. All of these are possible answers all the way up, depending on which X you choose. So if I needed to know if when X is 5, I could find what Y will be. It'll be 10, and now I don't have to run it through the calculations anymore. And so this lesson is just really helping you recognize that your tables will give you that XY coordinate, and you can graph that. They represent a pattern that's going on, so identifying what the pattern is can help you come up with an equation. Or if you weren't given a table, maybe you were given a graph with that information. Or maybe you were given a graph and you can say, okay, well, if X is 1, what will Y be in this linear equation? So there's multiple ways to go about it. And with practice, you should be able to kind of piece together what that line should look like. Or if you were given a line, what equation got you to that point. So go ahead and dig in, find the places you get stuck, and see if you can puzzle those through.